Okay, so just answers here, just for the answer's sake. Y bar is 60.8 millimeters. Then I'm gonna have, should I say IXX1 is gonna be what is IXX1 there, students? Do you get 57.86?
5, yeah. 5,79. Yeah, it's time to the power 6.
5,79. 5,79.
Yeah, 1,79 to the power 6.
Yeah, okay. You know the units. IXX2 is 1,836.
3, yeah. 36.
IXX3 is where's that guy?
5,22.
Yeah. IX total. Simple. Wat Matoso knows is he's big chief in this. Total is what? 12,85, right? Obviously, we added them up here. So that's what I'm particularly just looking for here. I mean, this should easily be around 3 marks. And always state, what's important, always state from where. This is from the bottom. So always state from where, it's very important, from top or bottom. This one would have probably been, this is probably 2 marks. This could have been 3 marks as well. So 3, 6, 9, 12, 15 marks. And you find IYY, there's probably an extra 2 marks. Something along the lines like that. So you might get a basic shape, but obviously, in the most shapes you get, it's what's in the textbook. It gives you an idea of what to expect. Obviously, I'll let you know if there's some awkward shapes. You will not be tripped up or anything. Because the section has a purpose. It's not just like just there for the sake of being there. Okay, if no one's gonna say anything, I'm gonna proceed, and we can work on those last two examples now, and then now we can conclude strengths. This police strength is going well, going fast and well. But yeah, I need to make sure my lectures for the next session is what they think. Anyway, guys, so what I've just done in the slides here, it's nothing spectacular. What did I just do now? Nothing spectacular.
So I feel like an idiot here. I'm not too sure exactly how you get your IX1. I know it's like 5.7 times 10 to the 6.
Your IX1?
Yeah.
IX1?
Yeah, because whenever I put it in my calculator, it's like
it's fine. Let's unpack. Let's unpack. Just for IX1, you don't know waste too much time. I mean, I did say I'm not asking questions. It's fine. So we agree with your Y bar from the bottom, right? Obviously, we can find it from the top, just for the sake of this here. So my total distance, yeah, 140 minus 60.8, right? So we had, what are we? Hold on.
I got 79.2.
79.2, yeah, exactly.
Yeah.
Top. So if we add it from the top,
it will be 79.2 minus 10.
That's correct, yeah, because you're taking it from here.
Because then I still get a Moose answer. So I'm not too sure if I'm doing it, putting the calculator wrong or.
I know what to do. So let me just quickly see. First is it's BD, so it's 60 times 20, right? Cubed. Hence power 4 plus your area is 60 times 20 times 69.2 to the power 2. Can you do this? I hope you all got this. You're gonna get a big answer. It's like 5786. Millimeters so,
I get 60 times 20 cubed over 12 times 60 times 20 times basically 79.2 minus 10 squared. I get like I get 2.3 times 10 to the 11. So that's why I'm
So
wondering.
again,
2.3 times 10 to the 11. So I'm wondering, I'm
This.
literally typing it in, yeah, times 10 to the 11.
Let me check.
So I'm
With that.
trying to figure out why I'm going wrong.
So Matoso, what do you have there? Instead of us farming here the whole time. I mean, I don't know what you're doing with this.
No,
If I
maybe
get
it's
five,
the calculator, yeah, because if you punch this, you get the answer 5,7. Maybe double check the calculator.
yeah, I mean, I don't know. I don't know. Like, as I'm saying, it's quite strange. You can't be getting that's impossible. Take a picture and show it to us. Okay. Anyway, we can move on from this. Back to our slides. So like I said, just for the slides, I just included it, the different formulas here for each section and how to derive it. This is for your IX is BD, D cubed. Can you see how messed up the curriculum is? I mean, the stuff is already taught in Strengths 3, but it's also mentioned in Fluids too. Do you guys use this in Havoc? I'm going to look for a summary table quickly.
Yes, we did use last semester
Oh, I see, okay.
for Centroid only.
No, for Centroid, I see, okay. That's fine. I'm just looking for a table, quick table to summarize. Like, I mean, it's kind of not but pointless, but yeah. I'll just have it here for the slides because obviously I think it is important. Okay, copy. So yeah, so we know that for circle, they're just deriving this. This is from Kurumi's other book. But for circle, your IXX is going to be pi over 64. D to the power 4. Obviously, you see the circular shape there. Not going to go through the deriving. Obviously, if you have a hollow cylinder, you're going to subtract the 2. So those are the shapes you can roughly expect. And a rectangle, it's not a combination of shapes in this question. So we're more focusing on the steel tables. So unfortunately for you guys, it's not that kind of show. Yeah, and this is just basically a summarized version of all those things over there. So nothing new really. You get the concept. But if I would ask you as a bonus question, maybe, you know, like the one we did over here, and you've got the answers. I'd ask you which how do I say this? Which will have a higher bending stress off the cuff. So we knew that IXX was where's that guy now? What is he? 249, and I was 59.735 times 10 to the power negative 6 meters 4. Which one will exhibit higher bending stress? Well, which is more?
Sorry, I found my error.
What?
I was timesing the whole way. I didn't put a plus there.
I'm glad you're laughing at yourself. So I guess no one's going to answer me. Okay, that's fine. You just see it in the test. All right, guys. So we're heading to bolt-up beams, and with bolt-up beams, we're going to be using our tables. All right. So a lot of this is going to be back and forth on a page, and on a bolt-up beam is essentially it's just a beam with different structural elements together. So in this case, here we're going to have, I'll show you one example. Here we have a U channel standing on its legs, a bar, and 2 unequal leg sections, right? That's a bolt-up channel. Another case would be this one over here, where we have a channel on top of an I-beam, And then another one is where we have nearly exactly the same setup, but the plate of the channels it's laying on its back, arguably on the web, and then it's also by a plate. So this is the kind of stuff you're going to expect. Doesn't get harder than this. So the example we're doing now is a good representation of that. We're going to try and solve this one. All right. So like I said, we're probably just going to do 2 and then we're done. But this one might take some time. It could take us a good 30 minutes to solve because it's just a lot of things to. Obviously, as I'm teaching it, I'm not just going through it. So I'm going to make sure everyone gets. Okay. So let's begin. So obviously, you guys have a nice 3-dimensional sketch. It's a nice 2D sketch as well. And the question reads as follows. A pull-up section consists of a bar with a rectangular section 200 by 300. Thank you. That's really easy to work. And 2 unequal leg sections, each with a mass of 1 to 5 by 75, each with a mass of 15 kilogram per meter, and a channel section of 200 by 75. A range is shown as figure 9.9. Calculate A, the position of the centroid, the second moment about the x, and y axis through the centroid. Same old question, students. So, first step, we find the centroid. That's the first thing in approach. But now, before we find the centroid, let's check. We're gonna have to check a few things. Let's get our areas quickly, right? Let's work it step by step here. So let's get our areas for each. I'm gonna call it area 1, area 2, area 3. Area 3 obviously is easy. That's just gonna be that's the plate, which is 200 times 300. We can work in meters or millimeters here really. That's entirely up to you. Let's work in millimeters for now. So what I want you to do now is go check on your table for area 1. Area 1 is a channel, and it's 200 by 75. I'm gonna go look at it so long, and you guys can tell me what it is. So go check on your table. Will be provided in your test as well, and your exam obviously. So I'm paging, going to look now. Channel. We've got this channel is 1 page of channels here. So, yeah. I'm going to tell you which page is that. I've got a 200 by 75. Is it there? And I found my area. I'm just waiting on you guys now. Please let me know what your area is. And then for the second one, I'm going to have a look as well. I'm just going to write my area down. This is my whiteboard here. And area 2 is an unequal leg. Unequal leg. That's going to be, what is this guy? 125
by 3.22 times 10 to the 3
millimeters
squared.
Hold on. Nearly there. I'm just checking both so that was it what? By 15. 125, 75 by 15. I'm hitting a bit of a hole here, eh? Because it's a bit different in the other textbook. But I think it tells the mass, so it's not really that difficult. So I think it's, yeah, I got it here anyway. I'll put it in the same. I'm just confirming with the stuff in the book. So you're getting marks for pulling off those areas, by the way, so just letting you know. Which table are you using, Mr. Kiefer? Because I got 3.22 exactly. So area number 1 is 3. Where is this now again? 3.22. Okay. We can work in you know, millimeters or whatever. Just working meters. You know? Otherwise I'm gonna get confused. What is my second area? Who managed to get that one? I'm just checking the textbook. It's lining up. So remember there's a problem with one of the questions here. I promised to contact Roski, but I couldn't get a hold of him. Even though I don't know if it's still live or not. Yes, that's one. Yeah, I got the right areas. It's all making sense to me. That's my second area. Beautiful, beautiful. So we can call it 1.1991. I'm working meters here, so you can work in anything really as long as the answers look the same in terms of the units. Yeah, okay. Good. That's good enough, right? So we found the areas. Obviously, we need this to find our y bar. So we know what our y bar is going to be. It's going to be the sum of your AY, your first moment of area, divided by your area. That's called the first moment of area. That's called your area. And we're going to find the centroidal axis. Cool. So we start on shape 1, obviously. So now this is going to be interesting. So we go 3.22 times 10, obviously the area. Now what is that y bar? So we are going to work from the bottom. That's the standard way of working. Anyway, you normally work from the bottom. You normally work from the bottom. And what we need to do now, obviously, so we got the center of wherever this guy is, and of course we don't know the center properly, and we need to find the center going up. So now, this is now the new part. So you have to head on back to your table and go look at your 200 by 75. Let me just find this section here. This is going to be AY. AY is 20.1. Let me see here. AY is 20.1. So what, we're going to talk through this. 20.1, let me just confirm. Obviously my height is, my breadth is 75, as taken. Just have to make sure. Also have to make sure. Okay. There's everyone. Yep. Oh, you guys, you can do it the other way around. I just keep it positive, you know, 20.1. I don't know how you guys work it. So just looking at your schematic like this, there's a distance here, and that's an AY distance. So remember what I mentioned, we take it to the edge, because there was a lot of debate around where do we take it, because it looks like we're taking it at a specific point. So I'm saying it now, we're taking it to the edge of the thing. So what we do, the total thing was 75, was a 200 by 75 channel. Simply say 75 minus AY, and AY in this case was 20.1, right? So if you do that, so it's 75 minus, 0.075 minus 0.021, 201, 20.1. So 201, there we go. Not squared or anything. That's definitely correct. Plus, this is going to be this is going to be extremely long. I just want to go my areas to the bottom so I don't have to write this again. Don't worry about this now. 1.91. Yeah, welcome to S4. Area number 2. Now, of course, for area number 2, it is imperative that you must be aware that there's 2 of these sections. So we have to combine both these areas. Fortunately, there's a metric on either side, so that's easy to work with. And in this case, that's going to be, I should probably say 2 times 1.91. Of course, this is where all the issues normally arise. So let me just go big brackets here, big square brackets times the round brackets. I should have enough space there. Okay, so looking at number 2, we once again have to look at the unequal leg. Is there a y maybe? Where's my unequal leg?
Sorry, so where did you get 1.91 times 10 to the minus 3 for the area of 2? Where did you get that?
On the table. Did you not get it?
I'm not too sure which table to look at. There's the one for channels, and then obviously the last one is the
It's unequal legs. Unequal. That's why I asked you on this now.
Oh,
Sir,
Just hold on, Mr. Matasso. Just give me a second. Did you get it, Alex? Now there. Just I want to resolve this one.
I'm there.
You got it now.
Yeah, my
Done.
clutch was a bit stiff. I didn't change gears. So yeah, a bit fast.
Okay. Noted. Okay, Mr. Ivano, go for it.
yeah, so I saw also the 1,91, but there is one 125 times 75 times 8, and this one is times 10. What is the difference there? Why we
I'm
choose
confused.
191?
Oh, okay. I think I know the problem. Let me just quickly see. I think.
Yeah. I also want to know that. Yeah.
Yeah. Well, don't worry. Just bear with me. I have this weird thing that keeps on my Adobe say content preparation is bloody annoying me. Anyway, I'm just gonna snip. I know. I think I know what you're asking me here. We talk about unequal leg now, right? It's probably have to look at the mass. Unequal leg. Where are you?
Yes, so he's right. You look at the mass.
Right.
Yes.
Look at the mass. Yeah.
Because if you look at the mass, there, it gives you for 15 kilograms. Yeah, that's right.
Yeah. So look at the mass. Yeah. Oh, it's a cover. Yeah. I knew people were not going to see that. Yeah. Okay. So just reverting back, we need to find now. What is this now? The Y bar here. And obviously this is going to be simple, it seems. So we just probably have to look at the height of this thing. The height of this unequal section is 125. This is confirmed. 125. Where are you? It's in my textbook here. It's going to be 75 plus what? It's unequal. So it's 75 for the channel, and then obviously mid there for the unequal section. So let's have a look. So we know 75 plus something. How's it 42.3? Can you please tell us exactly? Where's my unequal leg? Mr. Kiefer?
Following the table, sir, and there's a diagram that says
Oh, you are.
AX.
Yeah, there we go.
On my
AX, yeah,
diagram
there we
says
go.
AX is from the corner upwards.
That's correct, yeah. Beautiful.
And the 15
Now you-
kilograms per meters is 42.3.
No, it's correct, yeah. Thank you. So this guy is going to be 75 plus 42.3, right? Just to show you. But the case, I hope you're getting this, eh? You did ask. We have to work out in all of this table of shapes, and I hope you're understanding now why. Where am I? I'm gonna paste this here. Sorry. Open up. So obviously you have to check the orientation, and AX is over here, going from here to there. So this was 42.3. Obviously this on the channel, so 75 plus that 42.3. I hope that is clear. Yeah. Thank you, Mr. Kiefer. Good work. I hope that's clear to everyone. Last part, plug and play. There we go. See what I want to hear. Mr. Abreu,
Please, sir, just explain me just one more time, please.
Beautiful. It's fine. So Abreu, I'm going to share the table for you. So we can actually, obviously, you can actually see what I'm talking about. So I hope you can see the table. Now you can. And where is this? So if you add the 125 by, so if you look at the table of unequal leg, right? What's important to note is that we've got AX and AY. So remember what I tell you, AX is basically the position of the centroid. So if you look over here, can I sketch here? let's schedule this. Let's just assign anyway. So AX going up there is obviously it's orientated this way. So AX, it's in your table. It's column 1, 2, 3, 4, 5. Column 5. If you look at 120 by 75, you'll see 42.3. There. Are you with me? You got it now. That's AX. That's looking up from here. If this thing was orientated differently, you probably have to look at AY maybe. That's AX, AY, A subscript X. It's where the centroid of that section is. Mr. Rabi, you're not saying anything? What is confusing you?
No, I got it, sir. I got it. Thank you very much.
Okay, thank you. Great. Beautiful. Okay, let's get back to our whiteboard. And where were we now? We're plugging in plane, so 0.06. Obviously, this is going to be a bit easier, I think, arguably easier. So, 75. Obviously, this plank, it's plank. Why do I assume it's a plank? It's a 75 plus 100, I think. Yeah, because it's halfway. It's directly on the channel. So 75 plus 100. Or 0. Just obviously, you know this in millimeters. So obviously that's millimeters. So just be aware. I'm making. Okay, so let's find a centroidal axis. On my area, I think I made a mistake here. I must times this guy by 2. So don't forget, it's a total sum of your areas. Okay, so let's get into Y bar. Let's get that Y bar. So you notice you always find Y bar, like I said. So let's see who's on the line today. Got 27 students, which is good. 27 out of the 60. Mr. Doyle, Mr. Amasoud is here. Nicolene's here as well. Where's Annalisa? Jason also left. Oh, he's here, sorry. 128.4. That looks good to me. 0.1284 millimeters. Okay. Students, I hope you're all happy with this. This one is definitely around maybe 4 marks. This one is this amount of sections. Remember, one mistake is all over. So please check your work. So let's work it. IXX1. Right, we don't need to still work out other things. You know, we can go straight to the point here. And obviously we know this is parallel axis. Yeah.
Is your area all in millimeters squared?
No, it's in meters squared.
Meters, but then your area 1 is 3.2 times 10 to the minus 3. It should be millimeters. Isn't that millimeters squared?
No. It's not. I told I'm working in meters now.
Yeah. But there on the table it says 3.22 times 10 to the minus 3 millimeters squared. Right?
Okay. On the table it looks like this, right? Let me show you. This is why I'm showing you the units. It always messes up people. Let me go find a channel. An equal link channel. Where are you? Where's it guy? Where's it area? Area 3 point. Where can I see it now?
Yeah, it's table 2.4.
Yeah, 2.4, sorry. Okay, the channel, sorry.
The reason I'm asking, because it looks like you converted area 3 into meters squared, and then area 1 and 2 you left as millimeters.
Just follow. Yeah, that's why I show you with a millimeter thing. So if you have this, right, this is what's in the table. We're happy.
Yeah.
If I want to convert into meters, all I'm going to do is say this. So I know that millimeters is what? Times 10 to the negative 3. And I make that squared. Right?
Okay. Shit.
If I have this, that's 10 times to the negative 6. Right? And obviously, we multiply, we add exponents, whatever, and you end up with 3.22 times 10 to the negative 3 meters.
Oh.
So it's still the same values that your I guess, I don't know what you call this. And the exponent changes to negative 3.
Yeah, I need to have another 3 cups of coffee. So.
3 cups. I like that you know exactly how much. Okay, so moving along, right? So first shape IXX. Where's Mr. Doyle? He's been quiet. Mr. Doyle is still there. Niela's also
Hanging
been
on,
quiet.
sir, hanging on.
Oh no, man. I hate that hanging on surviving answers all the time. We should be swimming. Should be backstroking actually. So IXX, so let's go look at the first one. What is our IXX on the channel? Our IXX. Let's go look at our IXX for the channel. I'm paging over here myself. Table 2.4, no, 2.4 as Alex just said. And remember, it was important to note which axis to use, eh? And that guy is going to be 19.1. Great. Please, students, go find it and let me know if you can't find it. It is imperative. Don't want you guys to sit and suffer here. I think I'm right. I think anyway. No. I'm in the wrong place here. I'm looking at the channel, sorry. Yeah. So yeah, sorry. Just make sure I'm looking at the right thing here. What are they talking about here? Channel. Yeah, can you see? Yeah. We must look at, let me look at the channel. And this is very good. I like that people are picking this up. If you look at the table, turbo 2.4, I'm not going to be choosing IXX, I'm going to be choosing IYY. And IYY is 1.48. There we go. So 1.48. Beautiful. I wonder if I make mistakes deliberately sometimes. 1.48. I'm expecting questions, but if not, good work for me. Just carry on. So it's 3.22 times 10 to the negative 3. And then obviously H1. Now let's get at H1. We must always talk through the H's because this is what gets people. So we establish our centroidal axis, our Y bar, layman terms, our Y bar, and this was 128.4 millimeters. And this will be, if I'm correct, I know from year to year was, where are we going from? This is 20.1. So we should subtract 128.4, which is the total distance, minus this piece, which is going to be obviously 75 minus 20.1. I think I'm correct. Not always correct. Am I correct here, students? Let's just confirm our H there. So we just have to subtract that bottom section now, right? To find this from the center. I'm saying it's 128.4 minus 75. Okay, let me just make this in brackets. So let's see I'm correct. Always good to check your stuff yourself. 0.1.4. So did you guys get there? Am I wrong? 73.5. So let's look at the book. What do they have there? They have something different there. Do you have a look at what the textbook says there? They have 128 minus 75 plus 225. Why 225? Are we looking at, do we have the right distances there? Okay. Let's quickly just go revert back to our tables and have a look. So students, what is my H1? Let's all get this right. An equal leg. It's not unequal. Channel man. We are going AY, yeah, so it's going that way up. So it's 75 minus 20.1. How do you get 33.4? How is that possible? So the textbook, let me just have a look at the textbook again. So remember there could have been, there was an error here somewhere, if I remember correct. Not sure exactly where it was. It was, so obviously it's 128.4. This is what the textbook has, and they have minus 0.075. That makes sense. So they're minusing that whole section, but then they're adding now a 0.0225. Now that is now strange. What we did was, I guess S4, we said it's 128.4. And obviously we know it's minus 75 and minus 20.1. It is 20.1, I think. It should be right there. So it's going from here to here. So we're subtracting this piece here. So we know it goes from 20.1 going upwards. So that is going to be, this gave us, oh, I see why you got that value. Sorry, it is, we've got 54.9 here. Sorry, no, 54.9. So this one, yeah, is 54.9. 73.5. This is what we get. They get, what do they get? Oh, Mr. Minus, did you get their answer? They got a strange answer there. I don't know if I'm typing that right. Oh, sorry. I see my mistake here. So what's my H1? I'm saying my H1 is 73.2. That's my H1. Yeah, they get 75.9. The distance of the center of the x-axis. That's what they're saying. I think so too. What is I think so too? Yeah, our answer's right here. Yeah, if you look at, if you read the thing here, x-axis. I remember there was a mistake here. That's why I remember clearly. That was in this example. Yeah, the distance from the x-axis. If I look at the logic even, let me just see any logic. AY 47.2. Where is it now again? Jesus. Yeah, I don't see how they got theirs. But let's compute it anyway and see what we get. What is our answer? I'm hoping that we're right. So I'm saying this is 0.0735 squared. Okay. That's what I say the answer is. Is anyone not agreeing with our decision there? I'd like to hear why. And I get 18.8752 times 10 to the power negative 6 meters full. All right. What answer did they get? Let's have a look. they had an answer 20 something. They say the distance from the centroid of the channel to the x-axis. So, oh, obviously that's squared. I honestly do not know. So we're all happy with this one? I don't see how we're making a mistake. I honestly do not know. It's probably a mistake here. Is everyone happy? Is everyone happy there? All right, my IXX2. Checking out my channel. And my channel was a 125 by 75 unequal. And obviously what am I looking for is my inertia, and my inertia there, if you guys agree, is 19.7 about the x-axis. You guys agree with that at least? So I got there. Is the book agreeing with us? See. What am I looking at? No. Am I looking at the right thing here? IXX2. Okay, so my unequal leg 125 by 15. Oh, sorry, I looked at the wrong thing, sorry. It's 3,02. Forgive me. 3,02. To the wrong table. It's 10 to the -6. Our area we've got. Students, please engage. I don't know if you guys are following. Just give me some thumbs up there. Okay, that's my area. And then obviously we need to find our local from a local centroidal axis to the global, essentially, and that shouldn't be too bad. So we know it's 128, and in this case it's minus 75, and then minus the 42.3. That's definitely correct. So I'll just erase this here. So for the second one, we've got 128.4. So we know from, zoom in, we know from here somewhere that is 42.3. No, and we know that this is 75. So we're going from here to here. It's going to be 128 minus 75 minus 42.3. And that'll be our distance flight number 2. So 0.1284 minus 0.075 minus 0.0423 squared. Students, are you there? You're winning so far. Mr. Doyle, Mr. Demanis, Mr. Kiefer, grandson, Mr. Neto, Charlie, Mr. Kawa, guys there. Also x2, what is that? Oh, squared. I don't know what do you say, Mr. Demanis? x2.
There's two
So
unequal
mustn't be-
legs.
Yeah, there's two of them.
Oh, yes, times 2. Yes, that's correct. Now the times afterwards, yeah, that's correct. Yeah. So if you get that, you should get an answer of 3,257. 3,257 times 10 to the -6. Yes. Obviously, multiply by 2, you should get 6,514. What is this again? Times 10 to the power -6. Okay. Next one. You should all be experts now. So let's look at our next. Oh, next area. It's just your. It's going to be BD cubed, and B is B. What's B again? 30. No. Let's have a look here. We're finding. What are we finding now? Find the X. So it's B, yes, times BD cubed, okay? And that's going to be easy. 0.03 times 0.2 cubed divided by 12. Get the area. 0.03 times 0.2. And then obviously, let's sort this guy out. Going back to our sketch. It's not, don't think it's going to be that difficult. Just erase this. So we know that it's 100 from here. So 70. Let's start with our 75 and then let's go to 100. So I would say 175 minus 1284. So 175. So H3 is going to be 175 minus 1284. 128.4. And we can plug that guy in. Mr. Kiefer and Mr. Romanus, how are you finding this? Hey, what's that? Ms. Jack, how are you finding this? Yeah, it's okay, really.
Yeah, I see. You
And
can't
okay.
use the J. I see I was wrong with the J. It is IY and IX. I have to look
Of course you're
at
wrong,
these
Alex.
tables a lot more.
Of course you're wrong, Alex. So if you sort this out, let's quickly add it. I must be careful being normally arrogant. Like normally the next step you're always gonna mess up. One mustn't always be arrogant. You always be humbled somewhere along the line. Yeah, we should get 33,0294 meters 4. And we're at the end, and we just add them all together. Ix total. I mean, if you look at the textbook, you kind of get stuff like this. So it's really you shouldn't be. Sorry, you get a total of 59. Won't be 59.5 and 8.8752 plus 6.514 plus 33.0294. Get 58. So marks 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, it's around 12 marks. But I feel like this is just the beginning. Yeah, and it's yeah, it's not too bad, but you're gonna see what I'm gonna do. A lot of it's not difficult, man. I mean, it's just you just start to see how everything is integrated. That's the trick. Like I got people. I don't know. I don't say got people. People just weren't understanding concepts and they got chowed by it. But hopefully to improve in the semester. I mean, hopefully maybe it was me. IY, so IY guys. We just got to look at our table now here. So IY symmetrical. I think no, it's not symmetrical. We have to be careful here because our legs are away from that center there. So looking at the first IY, which is the channel. So I'm gonna do the IY channel, IY1. Let's go look at our table. With it IY1 is gonna be obviously IY is now IX here, just bear in mind. and we should get 19.1. IY2. So IY3, I'm going to work out quickly. I'm going to come back to IY1. So that's now dB cubed. So that's going to be 0.2 times 0.03 cubed divided by 12. Okay. What answer did I get there? Should get 0.45 times 10 to the negative 6 meters 4. And now for IY2, which I think I'm going to just throw him over here. We're going to look at our table. Of course, we know that there's 2 times of it, so we're going to look at our table again for the unequal leg. Where is that now? Yeah, so this question is way more marks. Where is that table now? Unequal. Where am I? Unequal. We're looking at I, Y. Probably a ruler to see exactly. 14.3. You guys get that? Is it 14.3? No, it's not 14.3. An equal leg. Where am I? At 200 by, is it 200 by 50? Was it by 15, right? We're looking at IYY. Let me just get it right. No, I must have done 0.821. So 0.821 times 10 to the negative 6 plus the area. The area is 1.191. And now we need the distance. Of course, this is multiplied by 2. I'm aware of that. So the distance won't be that difficult. So IYYX somewhere over here. So if you look at the table, if you look at your sketch, I'm gonna zoom it up. I'm gonna sketch this. Let me be more precise here. Precise, but it's IYY, and it's all over the place here. Now, know this. So this is the bar in the middle, and this is my leg. I was really hoping it's gonna sort itself out. And this is the center. Okay, so we know that this is 15, right? And obviously, if you look at the table, looking at your AY is 17.6. So it's somewhere here. So it's 17.6. And if by using my logic of what I've just been taught now, it's true. All I have to say is 17.6 plus 15, and that's going to give me some value, which is 0.0326. That's 15 plus 17.6. Right? And if we get this, we should get 2,81. And so in this case, you have to be careful with IYY. It's not always common, but it does happen. So just have to make your way. So let me say it does happen. Times by 2, you're going to get, what's this now? You get 0.5,702. And if you add all of them up, Yep, that's perfect, perfect. Add all them up, IY total is 25,25 times 10 to the negative 6 meters full. So what I will do is I'll say, okay guys, the section is a simply supported beam. The whole section now will be a simply supported beam now. So a whole beam. And then you know how integrated is simply supported beam. It's fixed there, obviously fixed there. From that, you have to find the moment using your shear force and bending moment diagrams. You have to find I using this formula. Of course, what is your Y bar? Your Y bar is your centroidal axis, which you've got. And if you've done that, your centroidal axis was 0.128. Guess what we can find? My times this. You can find our stress. Of course, we're bending across that axis in this case, right? So we bend across that axis. Let me just quickly see. What is my IXX total was 58.4186. And then times 0.4. So let's say I have a bending moment of 150 kilonewtons. So this is going to be 150 kilonewtons divided by 58.4186 times 10 to the negative 6 times the Y bar. If you do this calculation, this beam, ignoring its weight, will produce a stress of 3.29689 megapascals. Of course, what I'm assuming here, this bending moment, I didn't show you the structure of the beam, but maybe something like this. Obviously, it could have been a point load or whatever load. That's where we're going to. Mr. Kiefer, do you see that, students? Do you see that? I just extended that. Obviously, we'll do it in the next section, but I want to show you where we're heading. That formula there, it's the order. I'm way behind. I don't know what you mean. Oh, guys, are there any questions? I'm just showing you where we're going to. You don't need to know the last part, but I'm just showing you what is this all about. Any questions, students? We will be going on our extended break. Still trying to catch up. Okay, Mr. Kiefer, Jason, Mr. Kawal, Mr. Bason, Mr. Mutahul, Mr. Tele.
So the only question the question that I'm struggling with is like for your Y bar, why do you keep using 75, like your 75 minus 20.1?
That's the height of the channel.
Okay, yeah, it's the
height of the channel.
channel, and then your 20.1 is your what? Your AY, right? It's your AY. Yeah, there. Okay.
Yeah, that's correct. Yeah.
Okay, I just want to know why you use 75 as your common. Is that 75 from the base of the channel to
Yes.
your XX side to your X?
Yeah.
Okay.
Yeah, it's to the bottom of the channel to the top. Yeah, the bottom face to the top.
Okay.
The tables.
Okay. All right. And then IX1. I'm just trying to understand where you know IX1. In the book, they got 0.1284 minus basically 75 mil plus the 22.5. What is the 22.5?
That's incorrect.
Is it incorrect?
Yeah, it's supposed to be 20.1. Yeah. or not that value, but we worked it out.
Oh, fuck. Okay. And then,
Yeah, the book
but
was-
what is that? Okay. Okay.
I have no idea. I have no idea, honestly. I think it was. I honestly,
So
I
you-
look. I can't figure out. Yeah.
So this IX1 is basically your it's your your IX plus your area plus or times your Y bar plus your Y1.
Yeah, it's over here.
Y bar, I mean Y bar minus Y1. Oh, sorry.
It's over here. This is our one. Yeah. So it's 128 minus 75 minus 20.1. That's what so it's hard to like go back.
Yeah.
and-
So
you have to
that's
explain.
it basically. So it's Y bar minus Y1. Okay.
Oh yeah, I see why. Well, sorry, my. Yes, that's correct.
Okay. I'm just trying to understand it. It's okay.
Alex, you're holding us up. You want to move on? Are you still okay?
No. Gooi.
Okay. Yeah. So guys, I recommend full practice on your on the back of your exercises. But you have some more problems. This is also an exercise now. I'll just quickly show you. This one, centroid. Obviously find your centroid IX, IY is another one. A post and another one. This is the class test. This is also another one. I'm gonna make you aware these problems can be changed heavily. I can choose any section, right? I can choose literally any section. Remember, that's a 300 by 100 channel. I could easily choose or there's a taper flange and a parallel flange. I can easily choose a 175 by 54 or 180 by 70. For the I-beam, taper flange, I can choose a taper or parallel. I can choose a force. I can choose a 2 by 4, 254 by 2 by 4 by 73. The variations are endless. So the only thing is your God, your Jesus, your Messiah is, well, in this particular section is your procedure. So you can never fully prepare for the section. Yeah, we'll see. We'll see. The 4 subjects, I can't be nice. It's impossible. So I'm just making you aware that it can be endless. This can be endless. It's you have to just know the concept. And yeah, you can practice those ones. And yeah. Okay, there's nothing more than this. We are done for today. And for strengths and the marks allocation. Didn't I say this a few times already? I've said it like, how many times have I said this? I mean, I feel like people are not listening. Come on. You just say this is a 15-mark question. I literally put the marks in my stuff, bro. I mean, it's there. This was already like 12 marks, and this could have been like 15. This could be an extra 4 marks. This is an easy 20-mark question. The whole question is strengths are big marks. They're all going to be 10, 12 marks, 15, 20 marks straight. But if you make a mistake with the centroidal axis, it's over. I'm making you aware of that. It has killed many students, many students. Many students have felt victim to that.
So
Yes.
I'm just trying to understand. I see at the back of the book these steel sections are pretty much what you would use maybe in general construction or whatever.
Yeah.
But surely you would
That's
use
correct.
the second moment of area for like the ship's hull, because that's just not a uniform shape. So like if there was damage to the ship's hull and you were trying to find a replacement piece of material in order to, you know what I'm saying? It's not like just a generic
Yeah.
piece.
It's like, you see, the thing is, that's why I always want to show you guys more. There is so much. Like I have books on like ship design I was looking at some time ago. Like your education is just not enough. That's still like the main point. and there is just so much more detail in a lot of the stuff. You're at least, after your diploma alone, you're at least 2 years behind of 6 subjects per semester of like just like catching up in terms of like where the actual level is. Like there is a lot of stuff, you'll be amazed. And then once you have all that basis, one will specialize into a particular domain. Like let's say you go to structural design of ships, but it's not, you can master generally the whole thing, but there's like all the specifics on specifics, man. So the models will change. Like remember I told you there's applied strength of materials after this, which I've done. I've done strength of materials 4, and I've done stress analysis. And even that alone wasn't like the whole of everything. So I'm making you aware that there's like so much more, and it's hard to now like engage fully because, you know, like obviously this is the scope of this, and anyway, still there's a lot of stuff, man. I mean, it's the one thing I'm not happy with is like we focusing on a lot on beams here, but we could have actually replaced beams with shafts with supported bearings, like obviously like a long propeller shaft. You apply nearly the same concepts, finding bending moments and all of that. It's so yeah, it's obviously I've literally been here 2 years, man. So hopefully I can clean it up a bit. I don't know. It's a lot of stuff. A lot. There's like so much stuff. It's amazing actually. Anyway, just ranting. Okay, guys. So I think Mr. Levita's not having class. So I'd like us to take a nice extended break. So I'm waiting on him to just maybe just support him, and if he's going to give you any information. But let's get back at I'm going to say, so I mean, I don't use too much time. Obviously, I'm introducing a new concept, so it's gonna just be a new concept. I'm sure your mind to be completely refreshed. I'd say like you can start 1:15. Yeah, 1:15. So that's like an hour and 15 minutes. 1:15. Then we can push for maybe an hour and a half or so. Hour and a half, maybe 2 hours. But at least we'll be covering our work. So that's fantastic for electrodes. So I'll see you guys then. I'll post a thing on the group. We'll be having electrodes then. And yeah, I'll see you then. I'll probably have some breakfast now. But anyway, guys, cheers. And I hope you enjoyed today's lecture. And make sure you practice.